All right, in this screencast, I'm going to show you how to make histograms. In a previous screencast on univariate and bivariate data, I showed you this histogram. We've got a bunch of speeds over here, so that's the only thing that was collected. That's the only measurement. And to make a histogram, we're basically going to sort or distribute those observations into bins. And so in this case, we have 5 bins. The bin centers are along the x-axis, and then the frequencies are along the y-axis. Another example we looked at was a bunch of final scores in a class. So these are a bunch of students. Again, we put those data into bins. For example, we have this bin here. This bin with the red rectangle around it represents the total number of scores between 86.25 and 88.75. What we are displaying on the x-axis is the bin centers, and the bin width here for each of these bins is 2.5. Let's go back to the speed data that a police officer collected. Just wanted to kind of show you how we can decide the number of bins. In this case, we have 25 observations, and in general, some good rules of thumb are the number of bins. The number of bins, by the way, is selected by you, the creator of the histogram. The number of bins should not be greater than the square root of n, and the number of bins should not be less than the integer part of the log base 2 of n. And I'll show you how we can perform this calculation in Excel. If we did this, we would get the square root of n is 5, so we shouldn't exceed 5, and then if we plug this into the bottom equation, we get about 3. So anywhere between 3 and 5 for this particular example, where n equals 25. For fewer number of observations, like 25-ish, I tend to err on the side of greater. So I used 5 bins here, and that's what we're going to use when we create a histogram in Excel. So I'm over here in Excel. This is a file called car speeds, in case you want to work along with me. So I've got all the observations here. We have 25 of them. And let's go ahead, and first step is I'm going to do Control-Shift down, and I'm going to name that data just data. It's good to work with named ranges. So I've got these labels here. If you want, you can pause and then type those in and then resume when you're ready. But I'm just going to count the number of items in our data, and that's 25. I'm going to go ahead and name this n. And then we're going to perform that calculation. The square root of n here, the square root of n is going to be our actually these should be switched. So that should go there. That's the high end of the number of bins for 25 data points. The low value is the integer part of the log of n base 2. So that's how we can calculate that in Excel. And then we subtract 1. So some guy figured out a long time ago that this is a good equation for calculating the minimum number of bins. So somewhere between 3 and 5. Again, when I have such a small number of data points, 25, I kind of like to err on the upper end of this. So I'm going to go ahead and use 5. So up in the name box here, I'm going to put in n bins, and that's what I'm going to choose for my number of bins. We can calculate the maximum of our data using the max function. We can calculate the minimum of our data using the min function. And then the range is just the max minus the min. And so we have a range of approximately 10. The bin width, then, is calculated by taking the entire range, which is 9.9 there, and then we're going to be dividing by our number of bins, which I chose to be 5. And for this, it's right around 1.98, so that's about 2. So I usually perform a calculation, and then this kind of takes experience, but I like to use a nice round number for the actual bin width. So I'm going to put in a 2. And just so we can relate this back to the histogram here, that's where I'm getting the bin width of 2. So these bins are basically spanning 2 miles per hour in the data set. Okay, so now we have to look at the minimum, which is 27. And our first bin, I'm going to put the bins here, has to start below that minimum value. So I'm going to start with 27. And then if I go 29, so I'm going by the bin width here, then I think that'll work. And sometimes I just kind of do this by trial and error, and then I adjust the bin width as necessary in order for me to get the appropriate number of bins. I didn't need to go quite that far. So now I've got 27 through 37. That's a total number of 6 bin boundaries. So these are actually bin boundaries, 27 to 37, which will give us 5 bins. So 5 bins. I also like to put in a bin center here. So the bin center is going to be the average of those two, and I can bring this down. Okay? So now what we're going to do is we're going to use the histogram tool to count the number of items in our data set over here and place them into the appropriate bins. So these are going to be my bins. They're actually bin boundaries, but let's go ahead and name that bins. I've already named data. And now let's go over to the data tab, and we go over to data analysis and then histogram, and we click OK. The input range, I'm just going to put data. So I'm referring to all my data that I've named. The bin range, again, these are bin boundaries. So I'm going to put in bins. And then you can always specify where you want the output. I like to put the output somewhere in the worksheet. So I'm just going to click on cell F5, and I can click OK. And it goes through and it counts them. And the way this works is it goes, it counts for the number of items in our data set less than 27, and that's 0. And then it goes between 27 and 29, and I think it's greater than 27, less than or equal to 29. And then in this one, it says how many are greater than 29, but less than or equal to 31, and so on. So that's how it does this. What I can do now is let's just take the frequencies down. So I'm just going to copy these, and I'm going to paste down here, keeping in mind that the bin center is going to be the average of the previous two. So these are the bin centers, and I've got my counts, and I can go up here to Insert. I'm going to click on Recommended Chart, and we can just go ahead and click OK. It does a good job of detecting that. I like to delete the title. I'm going to add in these axis titles. So down here is going to be the bin center, and this is in miles per hour. And then on the y-axis here, this is just the frequency. All right, so there's a nice histogram of our data. And for some reason, I'm not getting quite the exact same histogram as I got when I showed it to you earlier. In other words, this particular plot, I think I inadvertently changed one of the data points in the file. But anyway, that's how you can make a nice histogram. Now there's another way to create histograms without using the histogram tool. So I'm going to show you the alternative way here. And just bear with me. If you are interested in what I'm doing, you can take, I have an Excel course, Everyday Excel, and I talk a lot more about this. But just for now, check out what happens if I do data greater than, I'm going to do this bin, multiply by data less than or equal to the upper bin boundary. So basically what I'm asking are two questions. Is the data greater than C16 here, which is 27, and so when we multiply, it's an AND operator, and is your data less than or equal to 17? And if that's true, it basically sums that and counts it. And when I press enter, we get 5, and I can drag this down, and we get the exact same thing that we got using the histogram tool. So that's sort of an alternative to that, and if you're interested in that, you can pause this and write down that formula. But I'm probably going to be using that in some of the histograms that I create in this class. The nice thing about that way is if your data changes, so maybe we have a a 34 here instead, then it automatically updates the data here. The histogram tool does not automatically update. So let me just wrap this screencast up by showing you what happens if we use too few of bins and too many bins. So here, if we would have placed this into 3 bins, it looks okay in this situation, but in general, when you use too few bins, you can't really see the distribution of this. It's more important when you have a greater number of observations. So you really can't see the distribution as well as you could. If you have too many bins, you're basically flattening out the distribution. And you can't really see a nice bell-shaped curve if the data is normally distributed. You can't really see the distribution because everything's kind of just flattened out. And by the way, you will be creating a proper histogram. You get more practice with this as I work you through the guided workshop for this week. So hopefully you learned a little bit more about how to make histograms in Excel. Thanks for watching.